We need to talk about your understanding of the number 0. In your daily life. 0 is a comfortable concept. It represents a total absence. If you have $0, your wallet is empty. If a car is traveling at 0 miles per hour, it is stationary. You view 0 as a floor, the absolute bottom of reality. You assume that if you take a region of space and remove every atom, every photon, and every stray wave of radiation, the energy remaining in that box must be 0. This is your first mistake. In the classical world, the world of your intuition energy is like a fluid. You can pour it out of a container until the container is dry. But the universe is not classical, it is quantum. And in a quantum universe, nothing is not a dry container. To understand why, you have to stop thinking of the universe as a collection of billiard ball particles sitting in a void. Instead, imagine that the entire universe is filled with invisible, overlapping fluids. We call these fields. There is an electron field, a photon field, and a Higgs field. What you call a particle is nothing more than a localized ripple in one of these fluids. A photon is a wave in the electromagnetic field. An electron is a concentrated vibration in the electron field. Your intuition suggests that if there are no ripples, the field must be flat. You imagine a pond on a perfectly still day, a mirror-like surface with a value of absolute 0. You think that if you could just calm the universe down enough, you would reach this state of perfect stillness. But the universe does not have a still setting. Physics tells us that every field has a ground state. This is the lowest possible energy a field can have. Your intuition insists that this ground state must be 0. Physics, however, insists that it cannot be. If a field were perfectly flat and perfectly still, we would know exactly where it is, and exactly how fast it is moving. And as we will see, the universe considers that level of precision to be illegal. Instead of a flat pond, the vacuum is more like a sea that is permanently agitated. Even when there are no particles, no large waves, the surface is still twitching. It is jittering with a restless, fundamental anxiety. This is what we call zero-point energy. It is the energy that remains when all other energy has been removed. It is the floor that isn't a floor. It is a basement that vibrates. When Richard Feynman and his contemporaries began looking at the math of these fields, they realized that the empty vacuum was mathematically indistinguishable from a collection of infinite harmonic oscillators, all vibrating at their lowest possible setting. You think you are standing on solid ground, but you are actually floating on a reservoir of infinite, microscopic motion. You have never seen nothing. No one has. Because the moment you try to create a true void, the vacuum pushes back with a frantic, unavoidable energy. The 0 you believe in is a mathematical fiction. In the real world, the void is heavy. The reason the vacuum cannot be still is not due to a technical limitation. It is not because our pumps aren't strong enough or our shields aren't thick enough. It is because the universe has a fundamental speed limit on how much information it is willing to give up. To understand why the vacuum screams, you must understand the Heisenberg Uncertainty Principle. You likely know the popular version of this rule. You cannot know both the position and the momentum of a particle at the same time. If you pin down where it is, you lose track of where it's going. But this is just one face of a much deeper, more unsettling law. There is another pair of variables that nature refuses to let you measure simultaneously: energy and time. In a classical universe, you could measure the energy of a patch of space over any duration of time and get a consistent answer. Space is empty. The energy is 0 at noon, 0 at 1 second past noon, and 0 forever. But the uncertainty principle forbids this consistency. It states, with mathematical finality, that the uncertainty in energy multiplied by the uncertainty in time must always be greater than a specific, non-zero number. Think about what that implies for nothing. If you look at a vacuum for an incredibly short period of time, the uncertainty in time becomes very small. To satisfy the law, the uncertainty in energy must, therefore, become very large. For a trillionth of a second, the energy of the empty vacuum can be almost anything. It can be massive, it can be violent. The universe essentially allows for a form of cosmic embezzlement. A field can borrow a massive amount of energy from the void, provided it pays it back so quickly that the books remain balanced. The smaller the window of time, the larger the debt can be. This is why the vacuum isn't empty. It is a frantic accounting department. It is constantly printing energy and shredding it before the auditor the laws of physics can catch it. If the vacuum were truly, perfectly zero, then the uncertainty in energy would be zero. But for that to happen, the time would have to be infinite. To have a vacuum that is truly nothing, you would need a universe where nothing ever happens, where time doesn't exist. As long as time flows, the vacuum must fluctuate. This is what we call quantum fluctuations. It's a polite term for a terrifying reality. At the smallest scales, the vacuum is not a smooth fabric. It is a chaotic, boiling soup of energy spikes. It is a static-filled television screen where the snow is the very foundation of existence. You think of empty space as a stage upon which the drama of the universe unfolds. But the stage itself is made of the same flickering, nervous energy as the actors. There is no quiet corner in the cosmos. There is only the noise that we are too large and too slow to hear. Because the vacuum is allowed to embezzle energy from itself, it does something that defies every logical instinct you possess. It creates things out of nothing. In your world, matter is a permanent fixture. You have a chair, and unless you burn it or break it, it remains a chair. But in the world of the vacuum, existence is a temporary loan. Because of that energy-time trade-off we just discussed, the vacuum is constantly giving birth to pairs of particles. An electron and its twin, a positron, will suddenly pop into existence out of the void. They didn't come from anywhere. They didn't have a parent. They simply appeared. But they are born with a debt. They have borrowed their mass and energy from the vacuum itself to keep the cosmic ledgers clean. They must find each other, collide, and annihilate back into nothingness. Almost instantly. We call these virtual particles. The name sounds like a mathematical trick, a way for physicists to make their equations work. You might want to believe they aren't real, that they are just ghosts in the math. But the vacuum doesn't care about your labels. These particles are virtual only in the sense that they are short-lived. While they exist, they have mass, they have charge, they interact with real matter. In fact, you wouldn't exist without them. The real particles that make up your body, the quarks inside your protons, are constantly being pelted by this vacuum foam. They are surrounded by a cloud of virtual particles that pop in and out of existence, shielding and shifting the real particles' properties. If the vacuum were truly empty, the math of your own atoms would fall apart. This creates a disturbing picture of reality. Imagine a lake. You see ripples on the surface and call them real waves, but underneath, at a level you can't easily see, the water is filled with tiny bubbles forming and popping, over and over, everywhere, forever. The vacuum is not a graveyard of dead space. It is a nursery of fleeting existence. It is a sea of ghost particles that are real enough to push on you, but virtual enough to escape your sight. You think of the vacuum as a place where nothing happens. In reality, more happens in a cubic centimeter of empty space in a single nanosecond than has happened in the entire history of human civilization. It is a frantic, desperate cycle of birth and death, happening so fast that the universe itself barely notices. But barely is not the same as not at all. If this foam is real, we should be able to feel it. We should be able to make nothing move something real. And as it turns out, we can. If you still believe the vacuum is just an abstract idea, a mathematical ghost story, you need to look at two metal plates. In 1948, a Dutch physicist named Hendrik Casimir proposed a thought experiment that should have been impossible. He suggested that if you take two uncharged, perfectly flat metal plates and place them incredibly close together in a vacuum, they will be slammed into each other. There is no gravity pulling them. There is no static electricity. There is no air to push them. There is, by your definition, nothing between them. And yet, they move. This is the Casimir Effect. It is the moment where the frantic noise of the vacuum becomes a physical hammer. To understand why, you have to remember that the vacuum is full of those fluctuations we discussed, waves of every possible size. Some are long and lazy, others are short and energetic. These waves are everywhere, bouncing around the universe. When you bring two plates together, you are creating a very narrow gap. In that gap, there simply isn't enough room for the long waves to exist. They are physically excluded. It's like trying to play a deep, low note on a violin string that's only an inch long. The string can't vibrate at that frequency. Outside the plates, the vacuum is a chaotic sea of every possible wave, but inside the plates, the nothing is limited. Only the shortest, tiny waves can fit. This creates a discrepancy. The vacuum pressure outside the plates is greater than the vacuum pressure inside them. There is more nothing on the outside than on the inside. The result is a measurable, mechanical force that pushes the plates together. Image. To parallel plates with many waves outside and only a few small waves between them. Think about the implications of this. We are used to things moving because they are hit by matter or pulled by a field, but the Casimir effect shows us that things can be moved by the absence of something. You are being pushed by the waves that the vacuum isn't allowed to have. Dotted is the physical proof that the vacuum is a substance. It has density, it has pressure, it has a texture that can be manipulated. If you were small enough the size of an atom, the vacuum would not feel like an empty void. It would feel like a thick, turbulent syrup. It would be a medium you'd have to fight through. We have measured this force in laboratories. We have seen nothing move something. It is no longer a theory. It is a mechanical reality. But this discovery brought with it a terrifying realization. If the vacuum has a measurable pressure, and if it's everywhere, then the total energy of all that nothing must be enormous. When physicists tried to calculate exactly how much energy is in the vacuum, they didn't just get a large number. They got a number that threatened to destroy physics entirely. Once you accept that the vacuum is a physical object with energy, you have to ask a dangerous question. How much? To find out, physicists did what they always do. They summed up the vibrations. They looked at a single point in space and calculated the energy of all the possible quantum fluctuations that could happen. In there, they added up the small waves, the smaller waves, and the even smaller waves. The math returned an answer that was not just large, it was infinite, according to the basic equations of quantum field theory. Every cubic centimeter of empty space contains more energy than all the stars in the observable universe combined. In fact, the math suggests that the vacuum energy is so dense that it should have curled the entire universe into a tiny ball the size of a marble the moment it was born. This is what Richard Feynman and his peers ran into: the ultraviolet catastrophe of the vacuum. The smaller the scale you look at, the more energy you find, and since you can theoretically look at infinitely small scales, the energy becomes an infinite wall that breaks every equation we have. Feynman was a pragmatist. He knew that since the universe clearly wasn't curled into a tiny ball, the math was missing something. To make the equations work, physicists invented a process called renormalization. It is, essentially, a sophisticated way of cheating. They took the infinite energy of the vacuum and subtracted another infinite number from it, leaving behind a small, finite remainder that matched what we see in the real world. Feynman himself called this hocus pocus and dippy process. He was deeply uncomfortable with it. He felt that having to subtract infinity from infinity to get a sensible answer meant we didn't truly understand the vacuum at all. We were like people looking at a massive, raging ocean and only measuring the height of the spray on top, ignoring the miles of crushing pressure beneath. This creates a haunting possibility that everything we see, planets, stars, people, is just a tiny, microscopic froth on the surface of an ocean of energy so vast we cannot even comprehend its scale. We are living in the remainder of a cosmic subtraction, but even if we use hocus pocus to hide the infinity, the energy that remains is not zero. It is still there, lurking in the background, and while it might be small enough to let atoms exist on the scale of the entire universe, it is the only thing that matters. The nothing is not just a background stage. It is the engine of the cosmos. For decades, the infinite energy of the vacuum was treated as a localized headache, something for particle physicists to hide behind renormalization. But when we turned our telescopes toward the furthest reaches of the cosmos, the nothing we ignored came back to haunt us on a scale of billions of light-years. In the late 1990s, astronomers measuring distant supernovae discovered something that shattered our understanding of the future. They expected to see the expansion of the universe slowing down, reined in by the collective gravity of all the matter in existence. Instead, they found the opposite. The universe is flying apart faster and faster every second. Something is pushing. We call it dark energy, but that is just a placeholder name for our ignorance. When you look at the math, dark energy behaves exactly like the vacuum energy we've been discussing. It is a constant energy density that belongs to space itself. Here is the horror of the vacuum. Matter dilutes. If you have a box of gas and you double the size of the box, the gas becomes less dense. But the vacuum is a property of space. If you double the amount of space, you double the amount of vacuum. And because the vacuum has its own energy, you have just doubled the amount of push. This creates a runaway feedback loop. The more the universe expands, the more nothing there is. The more nothing there is, the faster the universe expands. The vacuum is the only thing in the universe that gains power by simply existing. It is currently the most successful nothing in history. It makes up roughly 70% of the entire energy content of the cosmos. Everything you have ever seen, every star, every galaxy, every black hole is a rounding error compared to the sheer, crushing weight of the void. We are currently losing a tug-of-war against the emptiness. Gravity, the force that builds worlds, is being systematically dismantled by the vacuum. Eventually, the vacuum will win. It will push the galaxies so far apart that their light will never reach us. It will turn the sky black. You once thought of the vacuum as a passive container, a stage that allows things to happen. You must now see it for what it is, the protagonist of the story. Matter is just a temporary impurity in a universe that is striving to be empty. But even as it pushes the universe toward a cold, lonely end, there is one final, unsettling truth about the vacuum stability. If the nothing can change its mind, the story ends much sooner than we thought. We have reached the end of our intuition. We have seen that the vacuum is not empty, that it is a violent sea of energy, and that it is currently dictating the fate of the cosmos. But there is one final realization that brings us from physics into a state of existential awe. If the vacuum is a physical object, it can have different states, just as water can be a solid, a liquid, or a gas. Physicists suspect that the vacuum, this nothing we inhabit, might not be in its final, most stable form. We call our current state a false vacuum. It is like a ball that has rolled down a hill but gotten stuck in a small dip halfway down. It feels stable. It looks like the floor. But there is a much deeper valley further down. If the vacuum were to ever tunnel into that lower state, a true vacuum, the laws of physics as you know them would vanish in an instant. A bubble of this new nothing would expand at the speed of light, incinerating every atom, every field, and every memory of our universe. There would be no warning. There would be no heat, just a fundamental rewriting of what it means to exist. Image: a potential energy diagram showing a false vacuum and a true vacuum separated by a barrier. But do not let this frighten you. Instead, let it reframe you. For your entire life, you have viewed yourself as a solid entity moving through a void. You thought you were the protagonist and the vacuum was the background. You were wrong. You are a temporary vibration on the surface of an infinite, restless ocean. You are a brief flicker of something that the vacuum has allowed to exist for a moment. Every atom in your body is held together by the grace of these fluctuations. You are not separate from the vacuum. You are a complex ripple within it. We used to think that the history of the universe was the history of matter, of stars forming and galaxies colliding. We now see that matter is just the froth on the waves. The real story is the nothing. The vacuum was there before the Big Bang, and it will be there long after the last star has flickered out. It is the beginning, the middle, and the end. It is a silent, invisible, high-energy engine that creates everything and, eventually, reclaims everything. Image: a slow zoom out from a single atom to a galaxy, eventually fading into a vibrating dark void. You are not living in a world of objects. You are living in a world of activity, where even the empty spaces are alive with a frantic, unyielding energy. The void is not looking at you. It is you, and it is far from empty.